Hello friends, welcome again. Today we'll be solving a problem related to induction motor, and the problem is a 440 volt 3-phase star connected 50 Hz 10 pole squirrel cage induction motor has stator impedance of 1.2 plus J 2.4 ohms, and for rotor the standstill resistance is 0.006 plus J 0.022 ohms. Okay, and the effective turns ratio is 10 and the full load slip is 4%. If the motor is operated at full load when plugging is executed, what is the braking torque immediately after plugging? Okay, so what does plugging means? Plugging means that your rotor is rotating in one direction and your stator magnetic field, if it is a induction machine, this is your stator magnetic field. Okay, it rotates with synchronous speed and your rotor is rotating at an hour. This is your speed of the rotor, and what you do in plugging is you suddenly you reverse the polarity of the direction of your stator magnetic field. Okay, you make it opposite to the rotation of the rotor. Okay, so this is called plugging. So this is what is being done to stop the motor. It is done, so it's called braking. Okay, it's kind of a braking. So he's asking us what should be the uh, uh, torque immediately uh, after plugging. Okay, so let's start. So what we can do here is we have a turns ratio of 10. So what we can do, we can refer everything to the stator side. Okay, so this impedance, which is R1, impedance, that is R1 plus jx1, which is already in the stator side, so it is 1.2 plus j 2.4. Okay, so now if you refer the standstill impedances of the rotor to the stator, then you have to multiply by the square of the turns ratio. So r2 dash plus jx2 dash will be 10 square times your 0.006 plus j 0.022. Okay, so this is what you get. And now if you calculate this r2 dash plus jx2 dash, okay, now if you calculate this comes out to be 0.6 plus j 2.2. Okay, so now you have calculated the impedances with respect to the stator. Now one thing to see here is, as soon as you plug in, the slip becomes 2 minus s. Okay, because the direction of the stator flux is now opposite to the rotational speed. Okay, or the rotation of the rotor. Okay, so s is already given to us as 0.04. now s becomes the new s, I can say s new. Okay, it becomes 2 minus s, and this if you do, it comes out to be 1.96. Okay, so now our s new is 1.96. so this is calculated by s. Now what you can do here is, first we can find our current, okay, which is flowing. So this is a simple circuit. Okay, so what we can do now is uh, but our s new is 0. Sorry, it is 1.96. Okay, so this is also s new. Okay, here. So now what you can do is, we can use this formula. So what we can do is, we can use 440 by root 3 over under root, okay, under root r1 plus r2 dash over s new. Okay, this is s new whole squared plus x1 plus x2 dash whole squared. Okay, so this is our current which is flowing. Okay, now if you substitute all the values here, then what you get, I is equal to, you get your I is equal to 52.483 amps. Okay, this is our I. Okay, now once you have calculated your I, then we can calculate our air gap power. Okay, because we calculate air gap power, after that we can calculate our torque. So how to calculate air gap power? Air gap power is given to us as I square r2 dash over s new. Okay, this is our air gap power. Now I already we have calculated as 52.483 amps, okay, and R2 dash is 0.6 ohms, okay. Now again S new is 1.96. So from here if you calculate your air gap power, okay, air gap power comes out to be power, okay, it comes out to be 52.483 whole square into 0.6 over 1.96, okay. Now this can be equated to, this power can be equated to your omega s into tau, okay. Omega s is the uh, speed in synchronous radians per second, okay, and tau is the torque. So your torque is 52.483 squared into 0.6 over 1.96 into 1 over, okay, omega s, okay. If you calculate your omega s, okay, it comes out to be uh, omega s is omega s comes out to be 2 into pi into your synchronous speed, okay. If you calculate this synchronous speed for this 10 pole machine, it comes out to be 600 rpm, okay. You can calculate it by 120 f by p, okay. So you can do it by 660 by 600 by 60, okay. So now if you calculate your tau, it comes out to be 40.26 newton meter, okay. So this is how you can solve a problem related to uh, plugging, okay. Now this tau matches with option C, so C is the correct option, okay, for this question, okay. So thanks for watching.